Hello there. This is Ms. Nakayama, and today's lesson is 6.1c, solving equations by rewriting bases. So, we are talking about exponential functions. In case I haven't told you, I love exponents and logs, so I'm just loving this chapter. But our first property of equality tells us if b is greater than 0, not equal to 1, then b to the x equals b to the y, if and only if, excuse me, x equals y. And I don't know if y'all remember, but if and only if is what we use in a biconditional statement that says you can start here and end up here, or you can start here and end up there. Very important. So I call this, when you go from this to this, I call it like exponentiating a function. And you're going to see, we're going to talk about that a lot. So in this example with numbers, if 3 to the x equals 3 to the 5th, then I can ignore the 3's and say that x equals 5. Or if I want to say x equals 5, then I can exponentiate. As long as I have the same base, then 3 to the x equals 3 to the 5, or 3 to the 5th, however you want to say that. Okay, so let's look at these examples that we have. This is solving exponential equations, y'all, and we're doing it by rewriting the base. So all of these problems have the ability to write the bases, write both sides of the equation with the same base. Okay, and so I don't know if you remember back, we talked with our radicals, and I gave you a chart with your powers, and I was telling you how important it was to remember those powers. This is where it's coming back. So on this first example 1, solve each equation. So 4 to the 2n minus 1 equals 64. So what I need to do is write, I'm looking at my bases. One base is a 4, one base is a 64. I always want to see if I can write the higher one as a power of the lower one. So can I write 64 as a power of 4? And absolutely I can. So my left side stays the same. 4 to the 2n minus 1 equals 64 is 4 to the 3rd. And now I've got the same base. I can ignore them and set my exponents equal to each other. So 2n minus 1 equals 3, add 1, 2n equals 4, divide by 2, and n equals 2. And that's all it is. But we'll do some more because they're all a little different somehow. Okay, but this step, a lot of people don't want to write, y'all. And I'm telling you, those people who skip it, a lot of times miss the problem. So don't skip any steps on this stuff. All right, 1b says 5 to the 5x equals 125 to the x plus 2. So again, can I write 125 as a power of 5? And I can. So that means 5 to the 5x equals something. All I'm doing is rewriting the 125 as a power of 5. And 125 is 5 to the 3rd. So it's important to write it like that because you want to know when you're simplifying this, okay, you're only getting rid of the bases. So the base of 5 and the base of 5. So on the left side, I have 5x. What do I do to exponents when I raise a power to a power? What do I do to those things? Well, I hope you said we multiply them. So that means that 5x is going to equal 3x plus 6 because I got to do 3 times the quantity of x plus 2. Subtract my 3x, 2x equals 6, divide by 2, and x equals 3. Again, this step is so crucial. Do not skip it. All right, look at 1c. 1 over 81 equals negative 18x minus 15. Nope, I don't think I read that right. 1 over 81 raised to the negative 18x minus 15 equals 1 over 9 raised to the 3x squared minus 3x. So I want to write them both with the same base. Okay, so can 81 be written as a power of 9? By all means. And you can do it as 9, but you could also just do it as 1/9, which I think I'm going to do. Because if I do it as 1/9, the right side stays the same. It's just 1/9 to the 3x squared minus 3x. But how do I get 1 over 81 from 1 over 9? Well, that's just 1 over 9 squared. So now I have my same bases, and the base is 1/9 on both sides. So on the left side, that exponent, what do I do to those two exponents? Well, I'm multiplying, but I went ahead, I didn't multiply them out this time. And that equals the exponent that's on the right. So I'm going to distribute my 2. Negative 36x minus 30 equals 3x squared minus 3x. It's a quadratic now. We did those way back when, so it's assuming you know how to solve these. Bring everything to one side. Okay, and hopefully you notice that there's a 3 that goes into every one of those numbers, 3, 33, and 30. So I'm dividing everything by 3, x squared plus 11x plus 10, and that factors to x plus 1, x plus 10. So x equals negative 1 or negative 10. All right, last one in this group. All right, 8 to the 2y plus 4 equals 16 to the y plus 1. So when you're looking at this, we'll have to pause for a second. Sorry about that. So 8 to the 2y plus 4 equals 16 to the y plus 1. So as I said, you always want to start off saying, is 16 a power of 8? Well, 16 is not a power of 8. So then you got to think about what number can I write them both as powers of? And you might think 4, but 4 doesn't work because 8's not a power of 4. So you are still thinking of this. I'm still going to have my expression, but I need to get 8 and 16 written with the same base. And they are both powers of 2. So this is a power of 2. That's a power of 2. 8 is 2 to the 3rd. 16 is 2 to the 4th. So now I have them both as powers of 2, and now I can get rid of those bases and set the exponents equal to each other. So remember, when you raise a power to a power, it's multiplying. So this is going to be 3 times 2y plus 4 equals 4 times y plus 1. Then I'm going to distribute 6y plus 12 equals 4y plus 4. Collect my y's on the left and numbers on the right, giving me 2y equal negative 8 and y equals negative 4. Okay? Now, we have inequalities we got to talk about. Property of inequality for exponential functions. So, if b to the x, well, same kind of thing. B to the x is greater than b to the y. Okay, this right here. If and only if x is greater than y. Or b to the x is less than b to the y, if and only if x is less than y. So in a similar fashion, we get to ignore the bases and put the exponents in the same relationship that they start off with. And down here, it tells you it doesn't matter if it's equal to or not, inequality. So same kind of thing. Let's do it with, stop that, inequalities. So 3 to the 2x minus 1 is greater than or equal to 1 over 243. So I'm still got to figure out how to write them as the same base. So I've got 3 to the 2x minus 1 greater than or equal to 3 to the something. And I want to encourage y'all, okay? So you figure out, okay, 3 to the 5th is 243. But that's not 243, so that's not going to be a 5. And if you remember correctly, what creates that fraction is my negative exponent. So my answer is negative 5. And we're at that point where I get to ignore my bases. So 2x minus 1 is greater than or equal to negative 5. 2x is greater than or equal to negative 4. And x is greater than or equal to negative 2. All right, last one. Again, 2 to the x plus 2 is greater than 1 over 32. So when you're rewriting these bases, y'all, okay, 2 to the x plus 2 is going to stay the same. 32 is 2 to the 5th power, but this doesn't say 32. So that exponent can't be a 5. It has to be a negative 5. And then, as we've been doing, my bases are now the same. So x plus 2 is greater than negative 5, and x is greater than negative 7. And that's all we have with solving equations by rewriting bases. Thank you so much for watching. Please don't hesitate to come see me or email me if you have any questions. Y'all have a great day.